for day 2 of our sum and difference identities, another way we can use them is for these kind of problems on page 8. Number 1 says, find the exact value of cosine alpha plus beta if cosine alpha equals 3/5, tangent beta equals 5/12, and alpha is between 0 and pi over 2, and beta is between pi over 2 and pi. So that's a lot of information. Let's sketch it out so we can make sense of what we're given. Move my identities down here. I'm going to draw an alpha picture and a beta picture. Alpha is between 0 and pi over 2, which is quadrant 1. And they're giving us sine, which is y over r. I have to find the x, but I'll do that in a minute. Beta is between pi over 2 and pi, so that's quadrant 2. And tangent is y over x. I didn't put the negative with the 5 because negative 5 over 12 is the same thing as 5 over negative 12. So depending on the quadrant will depend where the negative goes. Now we can find the missing x and the missing r in the alpha and beta pictures with x squared plus y squared equals r squared. And this is a length of 4. And then the r here, x squared plus y squared equals r squared. The square root of 169 is 13. We're not going to leave that as the square root of 169. And now, if I expand out cosine of alpha plus beta, just looking here at my identity, that's cosine alpha, cosine beta, plus, goes with a minus on the right, sine alpha, sine beta. And each one of these 4 terms can give me a fraction from my pictures. So cosine alpha from my alpha picture is x over r. Cosine beta is x over r. Sine alpha, back to the alpha picture, sine is y over r. And sine beta is y over r. And now let's multiply. 4 times negative 12, 5 times 13. You can do the traditional multiplication if you want. 3 times 5, 5 times 13. We have a common denominator. Hang on, this is a little low. That looks funny. So now we can take negative 48 minus 15. You could think of that as plus a negative. So 48 plus 15 is negative 63 over 65. There's our answer. Now let's try number 2. Find cosine alpha plus beta if alpha and beta are in the first quadrant. Okay, that's nice. So let's draw those pictures. Here's alpha. Here's beta. So A is cosine x over r. Oh, B, x over r. X squared plus y squared equals r squared. Or if you recognize that often used Pythagorean triplet, B is going to out the beta picture is not one of our special 3 Pythagorean triplets, so we're going to calculate this one all the way. So we get the square root of 35. We want to expand out cosine alpha plus beta. That's my middle here. Plus on the left goes with minus on the right because cosine it changes. And now getting our 4 fractions, cosine alpha x over r, cosine beta x over r, sine alpha y over r, sine beta y over r. 4 times 1, 5 times 6. When you multiply an integer by by a square root irrational number. So 3 times root 35 is just 3 root 35. Subtracting. We have a common denominator, so we can make that 1 fraction. All right, one more. Now alpha and beta are in the second quadrant. Cosecant, oh, that's the reciprocal of sine. So this is r over y. This x segment will be negative because we're to the left of the origin. Tangent is y over x. The 4 is the negative. Here's another 3, 4, 5. You could calculate it out. I'm going to focus on the alpha one. X squared plus y squared equals r squared. This is another Pythagorean triple. Well, let's see, 25 squared. You can multiply that the traditional way. I think I'm going to multiply it with the little box method. So 20 plus 5, 20 plus 5, 20 times 20, 20 times 5, 20 times 5, 5 times 5. Add them all up. 400, 500, 600. This is 625. X squared equals 576. Oh man, what multiplies by itself to be 526? This is a Pythagorean triple I think we're going to write out so that we just have it memorized. So the square root of 576 is 24. So let's pause here a second. The common Pythagorean triples are, where can we write these? Maybe you should write these on your calendar. That would be really good. I'll make a little note here for when we post these. The legs being 3, 4 with a radius of 5. We just saw 7, 24 for legs and 25 for a radius. And then that other common one with the square root of 169 here has 5 and 12 as the legs and 13 as the radius. These would be good for the note, well, I guess for a note card or just to get used to on your formula sheets. so that you recognize them. It saves a bit of work, and since we have no calculator. Okay, let's finish this last one. Now that we've got our pictures, what's the identity we're given? Sine alpha plus beta. So coming to my sine, I'm going to expand that to sine alpha cosine beta plus, in between the angles, stays plus on the right. Using my pictures, sine 7/25, cosine beta -4/5, cosine alpha, sine beta. Wow, this problem is really testing our multiplication skills here. 7 times 24, 25 times 5. You can think of that in terms of money, quarters. If you have 5 quarters, how much money do you have? Or you can multiply it out. $24 times 3. Keep my denominator the same. Now I can subtract them. So adding 2 negatives, it's like adding our numerators with the negative. The directions don't say anything about reducing, so technically we can leave this answer. I kind of think it would be nice to reduce by 5 because 100 and 125 reduce, so let's do that. 100 divided by 5. If you need to, write it out. -20. 125 divided by 5, we already got that here, that's 25. And look, that can reduce more. 20 and 25 still reduce by 5. And there's our final condensed reduced value. Oop. Sorry about that. Okay, homework is not, you got to read your calendar carefully. For number 17, at the top it says evaluate alpha minus beta, alpha plus beta for cosine. So for 17, just find alpha minus beta. For 18, find cosine alpha plus beta. So you'll use the same picture for 17. No, I take that back. Not the same picture. 17, draw a picture. 18, draw a picture. And just find one identity that we specifically give you on your calendar. Same thing for 19, 20, 21, and 22.